In this video, we will do 3 College Board multiple choice questions pertaining to logarithmic functions. This is AP Precalculus topic 2.11. If you appreciate this content, please give it a like. Number 1. The function f is given by f of x equals 2 log base 5 of x. Which of the following describes f? Let's draw a little sketch. For b greater than 1, the graph of log base b of x looks like this. So the graph of log base 5 of x looks like this. And a vertical dilation by a factor of 2 does not change the basic look of this graph. So 2 times the log base 5 of x still looks like this. So we can use this graph to answer the question. Clearly, this is an increasing function. It is rising from left to right. So we can eliminate options C and D. I'm going to give you 2 different ways to decide whether the rate is increasing or decreasing. I would love for you to memorize this chart showing the graphical relationships between f of x, the rate of change of x, and the rate of change of the rate of change. The part that is relevant to this problem is the fact that if the original curve is concave up, then the rate of change is increasing. If the curve is concave down, then the rate of change is decreasing. F of x is concave down, so the rate is decreasing. That's how we know that the answer is B. Well, that's one way to know the answer is B. Here's another. On a graph, the rate is indicated by the slope. So an increasing rate will show up as increasing slopes, and decreasing rate will show up as decreasing slopes. From left to right, f of x starts off with very steep slopes. So this might be a slope of 4, or maybe a slope of 2. Somewhere in here, it gets less steep. So I'm going to put an estimate right here. Let's say that this is now a slope of only 1. And then later, it levels out even more, and the slope might be something like 1/2. Because these slopes are decreasing from left to right, then the rate is decreasing. So that's another way to know that the answer is B. Be careful. Here's a hypothetical I need you to be prepared for if you're going to use the second method. What if f of x was equal to negative 2 log base 5 of x? This would be a reflection over the x-axis, and the graph would look like this. The slopes from left to right still start off steeper and then get less steep. However, be careful because these slopes are now negative. So this first slope might be, let's say, negative 2. This middle slope around in here would be negative 1. And this slope might be something like negative 1/2. The question is, are these slopes increasing or decreasing? It's a little bit easier to see if you put the slopes in order on a number line. From negative 2 to negative 1 to negative 1/2, these slopes are increasing. So we would say that the rate is increasing. For this hypothetical, the answer would be C, because f would be decreasing at an increasing rate. Number 2. Which of the following could describe a single logarithmic function f? A logarithmic graph can only look 2 ways. If the b value is greater than 1, it's going to look like this. Or if the b value is between 0 and 1, it's going to look like this. In the first case, the limit as x approaches 0 from the right is negative infinity because of the way it's falling on the left. And the limit as x approaches infinity is infinity because of the way it's rising on the right. So this is one possible way a logarithmic graph can do end behavior. For the other version, the limit as x approaches 0 from the right is infinity, because in this case, on the left it rises. And the limit as x approaches positive infinity of f of x is negative infinity, because on the right it falls. These are the only two possibilities. Notice that the end behavior is always going to involve negative infinity or positive infinity, not 0 and not a constant. So we can immediately cancel out B and C. Also notice that the left and right end behavior are always opposites. It's either negative infinity and positive infinity, or positive infinity and negative infinity. It can't be the same for both. So the answer cannot be A. It cannot be negative infinity on the left and negative infinity on the right. All right, that would look like this. And that is not what a logarithmic function looks like. So the answer cannot be A, so the answer must be D. And specifically, D matches this one. It would be this graph. Number 3, the logarithmic function f is defined by f of x equals log base 3 of x on the domain from 0 to 9. Which of the following is true of f? We see that the base of 3 is greater than 1. So we know the graph of this logarithmic function, if the domain were not limited, would look like this, and it would just go off forever. Because the domain is limited to between 0 and 9, I'm going to cap this off. We'll make this endpoint a closed circle because it says x is less than or equal to 9. So 9 is included in the domain. So now we can answer the question. At a glance, I see they're talking about the existence of a maximum and or a minimum. Looking at our little sketch, we see that this graph will have a max somewhere, okay, at x equals 9, whatever the y value would be. Actually, we could plug it in and find out. But there will be no min, because as x approaches 0 from the right, this graph just keeps approaching negative infinity. So max, but no min. That's why the answer will be B. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.